strategy for example 5. We've been solving these exponential equations. And our strategy, we know we like to get a common base and solve, but that is not always an option. So we had to have other techniques. And so we've been adding logs to each side. Now Friday I told you that it's going to be much easier if you simplify and solve for your exponential first. So we want to start out getting that exponential piece by itself. In that case, we're looking for the piece that has the exponent, that 3 to the x. I want that by itself. So what do we do with this 5? So 3 to the x equals 6 over 5, or you can change that to 1.2, either way. Then, we can't get a common base, so what do?
Log on both sides.
You can do log base 10 or the natural log, either way. When did I tell you I would recommend using a natural log? If there's an e in the problem, yeah. And so then, we know with our properties of logs, the exponent comes down. And so then, what would we do? Okay. So the homework was the Math Excel assignment that I went ahead and opened Friday, but I told you wouldn't be due until tomorrow. Sometimes it will ask for an exact answer. This is your exact answer. And then sometimes I'll ask for a decimal. So when we type this in, you just have to remember every time you push the log button, it opens a parenthesis, so you have to close it. And we get 0.16595, so that would round to 0.166. You can always check it just by plugging it into the original. Is it going to work out exactly?
No.
No, because I rounded, but if I did 5 times 3 to the 1.666 power, sorry, typed mine in wrong. Typed in an extra 6. We get 6.000, so very, very close to that answer. All right, let's look at number 6. Did everybody get that when you plugged in your calculator? Okay, make sure you are plugging those in along with me. Thank you. You're welcome. So you know if you made any mistakes. So on this problem, what would we have to do first?
Add the 5 over.
Right, we're trying to isolate that exponential piece. So we add over the 5. And then what will we do?
Divide by 4.
All right. Can I get a common base? Nope. So we add our log on each side.
Can we just go ahead and put the...
So if you recognize this exponent is just going to come down front, you can go ahead and do that. But if I write it like this, I'm wrong. Does anyone know why?
Because it'll be 3 log x as something else.
This was all in the exponents, so if it's more than one term, when you bring it down, you have to write it in exponents. Or, sorry, in parentheses. So now I'm trying to solve for x. What could I do to get the x by itself?
Divide by that log.
Okay. And then what would we have to do? So our answer will be log 20 divided by log 2 with a minus 3 on the end. If I ask for the exact answer, this is it. If I ask for the decimal, then we just type that in. 3, 2, 1. Any issues with these? Lisa? Let's look at this one. So these last two examples are a little more challenging.
I got a question.
Mm-hmm.
Is the e's any different?
No, we just added a natural log.
So that's the ln.
Mhm. And the reason, if I said like e to the 2x times e to the 3x minus 1 equals 4. So first you combine these. If they're multiplied, what do you do with your exponents?
I don't know.
So we get e, definitely looks like an L, not an E, to the 5x minus 1 equals 4. And then we used ln. The reason being, it actually made things shorter. Do you guys remember when you had an ln and an e together, what happened? They canceled out because this has a base of e. And so if you didn't recognize it, if you use the other log, or if you kept it as a natural log of e, it's fine. It's just a shortcut if you don't catch that. And so then you just have to add your 1 and divide by 5 to get your final answer. So same idea, just a shortcut, if you remember that part. Okay, we did one of these the very first day in our notebooks when I introduced it to you, and actually it may have been this exact problem. But that's okay, we're going to do it again and review because that's been several days ago. So we can't isolate the exponential, there's 2 of them. We can't get a common base, so we start off adding our log on each side. And when I do that, can I go ahead and drop the exponent down?
Yep.
So we are trying to solve for x, but I have more than one of them. So we're going to have to get those on the same side. We have to start by distributing this log 8. That would be x log 8 plus 1 times log 8 is just log 8. Both of these have an x in them, so we'll subtract that over. If both of these have an x, we can't actually combine them because log 5 and log 8 are not like terms. But what could I do then?
Divide.
Step before that, we're going to divide. Before I actually divide it, what do they both have?
This is all you can take on next.
Take out the x. And then we're going to divide by that whole thing. So if I just said the exact answer, this is it. If I asked for a decimal, you have to be very careful when you plug this one in. Every log opens parentheses, so you have to close all of those. But we also have 2 terms on the bottom, so you need an extra set around the entire denominator. So make sure you can plug that one in for me. You should get 1.82. And you can plug that back into the original to check. try one more like that. Here.
Plug it in and it's not listening. So plus.
Alright. So on this one, we can't get a common base. We have exponents on both sides, so we go ahead and start with our log. Exponent comes down. Am I confusing anybody if I do two steps at once, where I write it and drop down my exponent? Since I have more than one x, what am I going to do?
Subtract it over.
Let's go ahead and distribute this first, and then we can put them on the same side. So it'd just be 1 log 3 or log 3 minus 2x log 3 equals x log 4. So we can add over the 2x log 3 because I want those x's on one side. Then they both have an x, so what should you do?
Take out x.
So then if I want to get x by itself, we would divide. So that's the exact answer. If I wanted a decimal, you need parentheses around each argument and then an extra set around the entire denominator. You can always check these by plugging it back in. If I put that in, I might get 1.5295 and 1.5296 for each side. So they are very, very close to one another. All right. So this is technically where I wanted to have gotten to Friday, but obviously we had that short class period because of the assembly. So I'm going to go ahead and do a few more examples, and then tomorrow we'll be caught back up where we need to be by the end of the day tomorrow. So our days are a little off, but by the end of the day tomorrow we'll be back on track. The second type of problem. So all of those problems on the Math Excel that I opened on Friday are like these that we've been doing today. They are exponentials. So you have to add your log and solve them, and you will have some time to work on that shortly. The second type of problem is problems that start with a log in them. So our goal, we have to look, if we only have logs on one side, then we're going to use the definition to change it into exponential form. But we have to isolate the logs before we do that. We want the log by itself. And the definition only works if it's just a plain log over there. And we will have to make sure to check our answers on these, because what kind of number does the argument always have to be? Positive. So we might get answers that don't actually work on these. So on this problem, I have to isolate my log. So what do I need to do? Okay, what is the base on this log?
10.
So then you can use the definition. We've solved some problems like this before, haven't we? We had some on the last quiz where we just had to do the definition. So 10 squared equals x plus 3. 10 squared is 100. Subtract the 3, and so x is 97. For checking, what I really just need you to verify is that your argument won't be negative. So is 97 plus 3 a positive number? Yep, so we're good. If I gotten like negative 97, I wouldn't be able to plug that in, so it would be no solution. Or if I got negative 97 and 0, both are my answers. 0 would work, negative 97 wouldn't. So it's possible to have no solution, one answer, two answers, lots of possibilities here. Okay. Let's look at this one. So this is kind of a step up from the problems that we had seen before, because I have more than one log. But we know these properties of logs now, so we are going to use this. What would happen to this 3?
Divide.
You could divide it over, but since this term,
Yeah.
I would have to divide it
It's
as
an
well.
exponent.
So another option would be to turn it into an exponent. If I want to condense these, that's log base 2. That would be an x minus 1 cubed. When logs are subtracted, what do you do with their arguments? Divided by 4 equals 5. So then, what can I do?
So that equals
Okay, so 2 to the 5th is 32. I'm trying to get x by itself. What would you do now?
Multiply 4.
How do you get rid of a cube?
Cube root.
Can we do the cube root of 128?
No.
Okay, let's just keep it. Then what would you do? We have the cube root of 128 plus 1. That's the exact answer. Or we could give the decimal. So you might have to take some steps to condense things before you can do the
Is
definition.
there any of them like that on the homework?
So what I'm going to do today, there's one Math Excel already open. I might open up a second one. They would be on the second one, not the first. So what I want to do, let's do examples 11 and 12, and then I'm going to stop for today. I'll let you guys work. So if I'm looking at this one, these both have a natural log, but this one doesn't. So what do you think we should do?
Same side.
Get them on the same side. You all right there?
Yep.
When these logs are added, how do you condense them? So x times x squared would be x cubed. A natural log is log base e. So if we change that to exponential form, we get e to the 9th equals x cubed. How do I get rid of a cube?
Cube root.
So we could type the cube root of e to the 9th in our calculator, or we could just, think this means,
Go in there 3 times.
yeah, it'd be 9 divided by 3, which is 3. So that's e to the 3rd.
plug that in, can't
You can, if you hit second and the natural log button, it brings up an E. So it's like 20.055 as a decimal. Alright, last problem for today. So, how do I condense these?
They're multiplying.
Mm-hmm. So if you want to multiply x plus 7 and x plus 8, what do you have to do? FOIL. So we would get x squared plus 8x and plus 7x would be 15x plus 56 equals 1. So 2 to the first. Two to the first is just 2. This is a quadratic. What do we have to set it equal to? 0. So let's subtract over that 2. Alright, what multiplies to 54 and adds to 15?
6.
Mm-hmm. Okay, so we get x equals, if you set each of those to 0, negative 6 and negative 9. I've done a really bad job of reminding you to check on these. I apologize for that. So, well, we have to look. If I put in negative 6, is negative 6 plus 7 positive?
Yes.
Is negative 6 plus 8 positive?
Yeah.
Mm-hmm.
Okay, so negative 6 works.
Yeah.
What about negative 9?
No.
No. So my only answer
Yes.
is negative 6 there. If we had checked on the last couple, e cubed, that's a positive number, so when we plug it in, that's fine. This one, we had a 6 point something, so if you subtract 1, it's still positive, so those are all good. So what I want you to do now